I'm sharing my screen as well. Is it visible?
Yes.
Okay. So last day there was machine learning was the point of discussion. Three parts in machine learning, right? Supervised. Then what is the second one? Unsupervised. Okay. The third one, reinforcement, right? Force main. Okay. What is supervised learning? Can anyone tell me? Gaurav, what is supervised learning in short?
Yeah, hi. So in supervised learning, we train a model based on a sample,
Okay.
a training
Y
set.
is present. Basically, y equal to fx. Y is there. Y is there. Y is present. That is supervised.
Yes.
Okay. Unsupervised, y is not present. Reinforcement learning, mix of supervised and unsupervised. It's a mix. We are not going to discuss this. It's a mix. But I will give you some example if needed. Okay. Okay. So now next, we classified supervised machine learning into a couple of parts. What are those? You remember?
Regression and machine learning. I think
Regression and
uh,
regression and
otherwise machine learning
regression and classification.
classification.
Okay. Okay. Regression and classification. What is the difference between regression and classification? Anyone? With an example, anyone?
Regression is trying to find the relationship between the dependent variable and the independent variable. Classification, I think it will be more towards segregating, different groups where
Okay.
two groups are
Okay.
So
homogeneous
maybe,
inside, heterogeneous outside. Yeah.
Okay.
Got it.
Yeah. Tell me.
yeah. So maybe a simple example. So regression helps predict a continuous quantity, and then classification predicts discrete.
Yes. And Y is categorical. Good. Some examples. Maybe one customer will churn or not churn, or employee will churn or not churn. It's a classification. Within next 3 months or not. The HR wants to predict. It's a churn. The employee is going to churn in next 3 months or not. Yes or no. Right. Fraud or not fraud. Fraud or not fraud. Maybe there is a third class. Not sure. Okay. Anything 1 0 anything classify any classification like anomaly detect no, so anomaly or not, that's a classification. So let's not confuse. So let's these two, default or not, default or not default. These are classifications, right? What is regression? Regression is something predicting salary. It's a continuous variable, right? Predicting maybe time taken by a system to complete something, time taken. Okay, these are the things. Prediction, continuous things is predicting. Okay. Now in regression, we have couple of things. Some algos. Some algorithm example for regression. For regression, these are linear regression. then maybe linear regression, maybe regression tree, regression tree. Here logistic model, here decision tree, random forest, regression, and this is called random forest classification. Forest classification. Okay, this is one. Now you learned neural network as well, right? Yesterday.
No, we did not have that session.
Okay, you didn't have that session. Okay. Okay. So these are the three things. So far we learned linear regression and logistic model, and today we will learn these forest trees, those things. What are those? What is the motivation? How these things happen? Little bit the algorithm as well. So these things we will learn. Okay. So first of all, what is decision tree? So let's start with decision tree. What is decision tree? Decision tree, we all know, right? So something. Let's learn from online. Okay. Let me show you how to. Decision tree. I'm searching and going to image. Yeah. Yeah. See, with friends, yes or no. It is windy. So whether you are going outside or not, that's a nice example. It is okay. With friends, yes, no. It's windy, then yes, no. Above par, no. Cold, yes. Below par, above par, below par, above par. So these are the, so basically these are splitting with respect to some criteria, right? What is the problem? It is not clear, but it is splitting with respect to some criteria. Okay. So is it A C? Okay, A B C. So it's a relationship between A B and C. Okay. Another thing. Let me find out something practical. Mm, okay. Anyways, let me create one. See, I have two variables, age and education. Age and education. These two variable I have. Okay. So based on that, I will try to map whether the person will buy computer or not. Buy computer or not. Computer buy, yes, no. Yes, no. Okay. So age 10, education maybe science stream student, yes. Age 15, science stream stream student, why? Age 60, retired bank accountant, accountant in bank, RBA, or bank, maybe bank 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 employee, retired bank employee. So No. So these are not rules. These are a data, a particular instance. There is a person ID as well. It's a person. There is a person, person one, person two, person three, something like that. Okay. Okay. And so on. Now tell me in this problem. So on, there are many data in this. Now tell me which one is your response variable and which one is your explanatory variable, or which one is your independent and which are your which is your dependent variable and which is your independent variable. Now this is the question. Janvi, here which one is my dependent variable and which one is my independent variable, or which are? Hello. It's a am I audible?
Yes.
Yeah. So Janvi, you there? Okay, I think she's on mute. Okay, Shoikat, which one is independent and which are dependent variables in this problem?
So can you hear me?
Yeah, I can hear you.
Uh, Age is independent
Okay,
and comp bay is dependent.
okay, okay. And
Education, on the other hand, is independent.
very good. This is independent, this is independent. This is dependent. That means this is my y and this is x1, this is x2. X1 and x2, right? And this person, this is the identifier, simple identifier. You don't use this for modeling, right? That is what I was asking. So now based on x1 and x2, I can create one relationship maybe. So x1 maybe student equal to yes, student equal to no, student equal to yes. Now this is my data. Again I am splitting this. It's a science stream student. Let me go there. So this is a huge data. Okay, so now assuming that this is a huge data, I will show you what I am trying to draw. So x1 is my age and x2 is my educational background, education background. Okay, so now I am creating one rule, just simple rule from this data. Okay, so this is my entire data, full data. This is my full data. Full data I am just splitting in this manner. So just x1 age is greater than 20 or age less than 20, age less than 20. Okay, so see here we have a small chunk of data. It's a smaller data. Here we also have a smaller data because it is coming from this data na. So these two data will construct this full data. So these are partial data with us, right? Where here age greater than 20 and age less than 20. Now will by compute. So now age and education, maybe education or occupation, whatever. So I'm just, it's a, if it is a student and science students, science background equal to yes, then yes, computer it will buy a computer. Okay, and if it is no, it will not buy a computer. N. Okay, age. So if it is IT domain, so buy a computer. Yes, yes. Non IT will not buy a computer. Okay, see, I am not generalizing. So this is coming from the data. Say suppose IT, non IT. So now what I did. This is nothing but, this entire thing is nothing but a decision tree. Now let me tell you, this is the full data. This is a full data. We are segregating this data with respect to this filter and this filter, and we are coming here. Okay. So these are called nodes. These are called nodes. And this is called root node, from where we are starting, where we have the full data. Now, after these nodes, we are splitting it further with respect to some condition. Now, this particular branch is age greater than 20 and science background equal to yes. Then I am seeing in the data, and this is another set of data. In this data, maximum are y, maximum maybe 80% or 90% are y with respect to that independent variable, will call by computer or not. And we are seeing in age less than greater than 20 and age greater than 20, and if age greater than 20 and the science background equal to no, this is no, science background equal to no, we are seeing 90% people didn't buy computer. Okay, it will not be 100%, but 90%. And here age less than 20, age less than 20, and similarly IT, non-IT, yes and no, the major proportion. So basically these are called terminal nodes. Okay, these are called terminal nodes. These are also data. In this data, if we have a major portion of y or major portion of no, accordingly we can take the decision. Okay, so now this is a decision tree. Now the question is, I cannot create in this manner. Now I will not have two variables. I will not have visibility to the entire data. The data might be in millions. So how I can do this thing manually? Is there any scientific way we can create this decision tree from the data? The input will be the data. Input will be the data. Input will be the data, and you will be feeding something in an algorithm. The algorithm will return you decision tree. Decision tree. So what you need to declare to the algorithm? So what is your y and what are x's? Which one is your x, which one is your y? And this algorithm is named as decision tree. Okay, this algorithm is named as decision tree. Okay, so far you understood what are the objective, what is the objective of this class. Any question? Hello, you guys are not understanding or finding it helpful? Just let me know.
No, it's fine. Yeah.
Yes, sir.
Yeah.
We can understand.
I am expecting, so this is a small class, it's not a 40-50 people class. I need some responses. Okay, please. Okay, so yeah, see, if you try to understand in this class properly and you follow the materials, you don't need to revise again and again. This thing, decision tree, we will learn. Okay, at least the concept you will learn. You can apply this anywhere in your business problem. So why it is so, just follow these 2 hours. So now this is your algorithm, which is decision tree. Now, so to start the algorithm, to understand the algorithm, so first what we did, let's revisit the decision tree. I am taking age first, and after this education or occupation, right? I am taking age first. I could have taken this occupation or educational background at first and after that age, right?
Mm.
Okay.
Yeah.
I could have taken that, but I took this way. Okay, so how model will elect which one to go, which one first we should go for? The algorithm will determine how. The algorithm, decision tree algorithm, determines that which variable to use for split, first split and second split and third split, which variables to be used. That there are 2 techniques to elect that by the algorithm. First one is Gini index, and second one is information value. Okay, for very first day, you might keep things forgetting. You with a continuous revise, This will mix with your blood in your brain completely. Okay, so that's why I referred that blog. That blog is very much standard. So I will, instead of taking you through the algorithm itself, I will take you through the blog properly. Okay, so Gini index and information value, let's read it together then. Okay, so now it's a very beautiful examples are here. Okay, Gini split and Gini index. Okay, the decision tree type is called classification and regression trees, cart. And information gain and entropy, this is called ID3 and C4.5. These are types of decision tree. Okay, so you term this as decision tree, you don't need to go into these naming conventions. In these namings, you just directly term this as decision tree. Okay, so see, different algorithm, different papers. That is the only reason. Okay, so now using Gini split, Gini formula is this: 1 minus 1 minus pi square. Pi is the proportion. Pi is the proportion, and with what proportion? Let us find out. Let us find out. Okay, can you quickly write this data in your Excel sheet? Possible? Let me send you. Let me send you. So you all are familiar with Excel, right? Yeah, properly copied. Let me last variable. This is the data set. Sample. Example data set. Example data set. Hmm, where is the chat box? I hmm, okay. Let me email this. Okay, some problem happened here. Hmm. Okay, so you received my email with all the data set I wanted to share. I am just sharing with you that. Okay, so just download that and keep that in same folder and let me know. I'll give you 2 minutes, 3 minutes time for that. Okay, let me share everything. Whatever is there with the meeting invite from uh, please download these files and save it to in your uh, in your drive or in your hard disk, one single folder, in a single folder. Okay, Let me know once you are done. I just sent. Let me know, please. Some response I'm expecting once you are done.
Sir, I have been using the tab. I don't have access to laptop. Is it fine if I do it later on?
Yeah, yeah, it will be it will be okay. No problem.
Thank you, sir.
Yeah, but make sure you understood. Then otherwise you should ask. Okay.
Sure, sure.
Okay. 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 Now, so I'm starting. So this is my y variable here. Okay. This is my y variable. This is my x1 and x2. X1 and x2. Okay. X2. Now let us go to the blog. Okay. What it is saying. So this is the formula. First, so Gini index for var1. It is showing. Gini index of var1. So for now, let's understand the calculation empirically. Later you will read this blog and we will understand the concept why. The answer why you will get in this blog. First, let's understand. This is a bottom-up approach. So first, so though this is my class is A. So var1. So how many values are in var1? 1 and 0, right? If var1 equal to 1 and class is A, how many examples are there? 1 by 4 instances have class equal to A. So in A, how many examples are there? In A,
5.
in A, how five examples are there. Naturally, in B, how many? In B, 5 examples, right? Okay. So I think we missed something. A 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No. This is fine. This is fine. Okay. So how many cases are var equal to 1 and class equal to A? Give me the count quickly. Var1
1.
class A. How many?
1.
1. Good.
And B is 3.
Okay. So and total 1. Total 1
Total 1 is 4.
4. Very good. Now what it is saying, var1 and class B. var1 class B.
3.
Class B. How many? 3.
3.
var1 class. See y. So this J column will always have your y, and this column always will have your x. You will have your x, and this is the count, and this is the proportion.
And why do we have 4 in total? I mean, shouldn't it be 5?
Yeah. So four is I'm counting var1. How many var1 is there?
Okay,
How many
where
one?
one is okay. Where
Yeah.
four.
That is something we need to.
Okay.
Yeah. So see, the splitting, it will be used for splitting. So just remember that the thing you are going to split with, you need to count that. Okay. So this is my y. Y is not getting. So basically, we are segregating y by splitting this with respect to this variables, right? X variable will also will take the total from. So
Okay.
B 3. Then how many var1? Then again 4, right? Now what is the proportion? Proportion is this 1 by 4. Sorry, this divided by this divided by this. And now Gini formula is nothing but Guinea from this is nothing but Guinea for var1, var1 Guinea. Guinea for var1 will be 1. Guinea for var1 will be, the formula is 1 minus power, actually square, this 2 minus power this comma 2. Okay, let me cut and paste this. Okay, that is what we can see. It is matching with this calculation, right? So this is something. So for var1, so var1 what we did, var1 also, so var1 has how many values? var1 equal to, var equal to 1, sorry, var equal to 1, var equal to 1. Let me write this properly, var equal to 1. Oh, sorry. Oh, var1, that's why. var1 equal to 1. In that manner, right. var1 equal to 1. So Giri var1 equal to 1 then. So, okay, can you calculate this var2 Guinea by ourselves? Just let me know how much it will be. You can see from the blog as well. Yeah, you just, but I insist you should calculate, otherwise you will forget. Yeah, I'll wait for 2 minutes.
But matlab for VAT2, where do you take the cutoff, right? Matlab, so in the
var2 I am not yet there. var1 equal to 2. Can I calculate this var1 equal to 0?
okay, VAT1 equals
Can I,
0,
yeah,
yeah.
var1, okay, I told you var2 na, sorry.
Yeah.
var1, for var1 equal to 0, I need the Guinea. Okay, you got that? Let me do this quickly.
0.44.
0.44. Okay, VAT2. So now tell me quickly these values. VAT2.
Okay, VAT2 is 4
Sorry,
for A.
var1 equal to 2. This is class 1. Class 1. For class 1, how many it will be?
Class A is 2,
Class A is 2.
B is 4,
Class B is 4.
total is 6.
Total is 6. And here also it will be 6. Now I can drag this formula. Right? 3, 3 and 6, 6, right? Something like
Yeah,
that.
yeah.
Okay. Okay. So what I can do. See, it is taking from this and var1 equal to 2. Okay. Okay, so basically now this is a categorical variable where x1 was a categorical variable. For this categorical variable, what we did, we created we checked this for each and every classes. So if it were three classes, 0, 1 and 2, 0, 1 and 0, so here var1 equal to 1. Okay, var1 equal to 0 na. Sorry, var1 equal to 0 here. Var1 equal to 0. So same thing, calculation will be same. Var1 equal to 0. I just wrote it to 0. So if it is 0, 1, 2, then we would have calculate in this way. So var1 equal to 2, for that we needed to calculate class A, class B, and accordingly we need to calculate the Gini. Okay, in this way. So now, so this is a categorical variable. We can observe this is a categorical variable. And what is this? This is a continuous variable. That what he asked, right? This is a continuous variable. For continuous variable, so we need to create a cutoff. We need to create a cutoff. We need to define a cutoff for continuous variable to convert it to categorical variable. Otherwise, this Gini will not be. So that's why decision tree is works well for categorical variables. Okay, because there is always already a intuitive segregation. Otherwise, we need to do trial and error for different cases. We need to do trial and error. There is no such thumb rule. So sometimes you can create 4 classes. So some ways of deciding the cutoff I will explain. Some ways. For categorical X, no segregation needed. Category is no segregation needed, because so only what is for all categories we are going to calculate the Gini. Now for Gini in continuous, Gini calculation in continuous case. For Gini calculation in continuous case, so we might some couple of thumb rules. We might use Q1, Q2, and Q3. Based on this, we can create three parts, like variable 1 less than Q1. This is one class. Variable less than Q2 greater than Q1, and variable greater than Q2
One less
greater than Q2, and sorry, less than Q3 greater than Q2, and variable greater than Q3. Four partition we can have. This is one thing. Another thing, you can use greater than median or less than median, or greater than. So if your data is it's a like for insurance data. Insurance data you can have 3 classes, right? Less than 18. So some business driven logic you can also use. Less than 18, maybe 18 to 30, 30 to 40, 40 to 50, 50 to 60, and 60 plus. So insurance treatment of these buckets are homogeneous. So business decisions, so 18 to 30 more or less the insurance are similar. It's a low price premiums you need to pay because your age is very less. Okay, now from 30 to 40 it's the intermediate one, a little high the premium prices, because there is a risk factor of getting sick, right? 40 to 50 it is high, 50 to 60 more than that, and 60 plus is very costly. 60 plus is very costly. I tried to take it from for my father, but it was very costly that time as well, 2 years back as well. Okay, he was 67. So in this manner, so some business driven logic can also you apply. Okay, here demonstration purpose they use couple of cutoffs, but that is not that is not something we need. That is not very much deterministic. They did with a deterministic way. They did it after seeing the variable that this, if we take this cutoff, there will be good distribution. Okay, so business driven and quarterly. And another way you can use this as well. That is depend, maybe third is you can use 33 percentile and 66 percentile. You will get 3 buckets then. Less than 33%, 32 to 63, 1. This is 1. This is 2, second part, and this is 3 maybe 66 and plus. In this way you can also do this. Okay, greater than median, less than median. So you understand this Q1, Q2, Q3, these things, right? What is Q1, what is Q2 and Q3, or this percentile concept?
Yes,
Yes.
sir.
Okay, okay, good.
Yes, sir.
So you understand. So does that answer your question? Who was asking? Gaurav, I believe.
No, I was asking. Yeah, yeah. Fine enough. So basically, yes. So basically, we'll have to convert it into categorical,
Categorical
either
variable.
binary or more, and
Yeah,
then sort of
yeah,
calculate the.
yeah. That's why decision tree is works well for categorical variable. That is the answer. This is the answer, because always we need to tweak the continuous variable. We cannot take the original continuous variable. Always we need to tweak something. But though this tweaking is done within model, the model itself does this. If you are supplying continuous variable, you don't need to do this manually anything, but you, if you can define, you will have better control. Suppose you are dealing with the insurance price problem, then you will have better control. Otherwise it might come less than 35 something, 35 to 50 something, maybe 50 to 57 something, and 57 to 92 something. So if model is model is creating these partitions by using the data, it might not be meaningful to you, it might not be interpretable by you. That is where we need to understand the business of the variable, business behind the variable, why we are considering this, and how we are going to measure this as an issue. Make sense?
Yes. So generally, when you are using any software, it sort of, if you leave it like that, it gives
Yes,
a sort of
we
breakup
will
as to when
we will
partition.
see, in we have in Python, sklearn, scikit-learn, we have a library. That library will do this for us, but we need to understand the background. That's why I'm discussing. Okay, we will do that as
Yes, yes.
class.
This is helpful.
Okay, who was that?
Yes, and it. Yeah. So basically, you got to understand how the entire.
Okay. Okay, now giving this VAT. So now this is very easy. See, the similarly, I am not gonna calculate this again. So 32 they took for VAT2. VAT2 is a continuous variable again. 32 they took, and for 32, how many cases are there of class A? 5 by 8. 8 is the total number of greater than 32, I believe. Okay, this is 33. 1, 2, 3, 4, 5, 6, 7. No, 5, 6, 7, 8. 8 cases. See, that's why it is 5 by 8. Class A is 5 by 8. So always class A, this class Y variable is always getting used. But Y variable is only getting used to calculate the match. No, the denominator is nothing to do with Y variable. The denominator and the weight we are finally uh, okay. So later let's do that, understand that later. So two things. So we are always going to use the count of the original variable in the denominator. Okay, so vad1 vad2, so vad1 vad2, it is coming as, for vad1 it is coming as, sorry, for vad2 greater than 32, it is coming as, for vad2 greater than 32, how much it is coming? Vad2 greater than 32, it is coming as this one. Okay, VAT2 greater than 32, and for VAT2 less than 32, it is coming as 0.375, 0.375. Okay, 0.375 it is coming. Now suppose Gaurav and maybe Gaurav and Choikat bought something. Okay, Gaurav and Choikat bought something, and They bought food. Maybe they are very calculative. They both are very calculative. Uh, they bought 10 burgers for their home, and Gaurav paid 40% and Soikat paid 60%. The 10 burgers. So how many burgers Soikat will take at home out of 10?
6.
6. And Gaurav will take the rest 4. Okay. Now here it is also the same thing. So the weight will be how many? The weight. So these are the guinea. So these guinea are for particular variable within the bit, the particular variable partition within the variable. So this is these two construct one variable that is called var2, right? This is constructing one variable that is called var2, right? And these are constructing a variable that is basically constructing var1. Now in var1 this is the case. So this is a detailed calculation, that's why it is two lines. For var1 equal to 1, how many examples are there? And for var1 equal to 0, how many examples are there? We need to multiply that proportion with the guinea to get the final guinea of var1. Just that. Okay. So how many here? 4 by 6. Then 4 by 10 into 3.375 and 6 by 10 into 0.4444. And here 8. So this is the count is 8 here. 8 and this is 2. We counted now. So it will be 8 by 10 and 2 by 8. 8 by 10 and 2 by 10. 8 by 10 into 0.46875 and 2 by 8 into 0.375. Okay. 2 by 10 into 0.375. I think that to greater than 30, we have to be index 0.475, 4675. Okay, Gini index for here less than it was actually 0. Okay, sorry, I pasted wrong thing here. I didn't calculate. So 0. This will be 0. So in this way, you can calculate the weighted Gini index. Okay. So till now, any question you have? Okay. Now let's go to the original purpose. The purpose was to find out the variable with which we should split first. The purpose was which variable which will be considered for first split. Now there is a thumb rule. Let's understand this numerically empirically for now. Whichever is less, this weighted Gini of whichever. So now for var1 we have some value, and for var2 we also some value. Final value, that weighted average, right? So what was the weighted average? Let me copy this. So var1 less than 40, var1 greater than 32, greater than 32. Okay, weighted Gini. Yeah, 0.375. Sorry. VAT2 means if we are splitting using this VAT2 greater than 32 something and VAT2 less than 32 is another portion. In this way, if we are doing, then it will be 0.375. And here VAT1 equal to 1, this will be 1. So 0.41667. 41667. And now thumb rule is lesser the better. So if this is less, then VAT2 we should take for further first splitting. So our decision tree will start. Our decision tree, we have full data. This is our full data. Full data, we have var1, var2 and y, right? This is var1, v1, this is v2 and this is y, right? This is of my full data. Now I am segregating based on VAT2. So if VAT2 greater than 32 is something, VAT2 less than 32 is something. So now we have another set of data, which is a subset of the original data. Again, the question will be, again, there will be V1, there will be V2, and there will be Y. There will be V1, there will be V2, there will be Y. Again, there will be a question. From here, if we forget this, let's what next? What next? If we can, if we again start from here, so again the same thing it will calculate. The algorithm will calculate. It will calculate V1 and V2 Guinea with respect to this smaller data set, and V1, V2 Guinea with respect to this smaller data set as well, and accordingly it will split. It may happen, again it is splitting with the same variable. It may happen. Okay, it may happen. It is splitting. So maybe this is where VAT2 less than 32. Then again it is splitting in this way. VAT2 less than 20, VAT2 greater than, it's a 30, it will be bounded by 32, greater than 20 and less than 32. In this way it is splitting. Further it will split. In this manner it will keep splitting. Are you getting my point?
Yes, sir.
Okay, okay. Now now when it will stop? When it will stop? It will stop if we have a good enough purity in the sample. Purity means either all 1 or 0 in class, all 1 or a majority proportion of 1, maybe 90% 1. 90% 1 in the class variable. Class variable, what was class variable? Class variable is my dependent one. Okay, so if we have a data set, so in every node contains a data set, right? You understand that, right? Every node contains a data set. We are getting a data set where everything is in class A is A. Oh, or not all 1. What I am doing? So we will stop where so here I am seeing in class variable, class A is 90%, 95%. Class equal to A 95%, and naturally class equal to B is 5% in this node. And here I am seeing class A is 50%. Naturally, class B will be 50% as well. Then it will keep on splitting. Further split it might need. This one might need further split. Here we are seeing class B is 90, 95, 91%. Here I am seeing class A is 100%. 100%. Everything is class A. So the purity is something we need to judge, or the decision tree judges based on the percentage of the different class of the variable we are considering in our discussion. The percentage of difference. So we have two values in class A and B. That might be A, B, C, D as well. So it will check the purity with respect to one variable. If D percentage, if it is a case of 4 variables, A, B, C, D, if D percentage is 95% and rest is 50%, then it will say it's a pure data set and decision tree will stop splitting. In this way, decision tree works and works and stops. Okay.
Sir, can you repeat this termination part another time?
Yeah, sure. Why not? Let me clear. So see, so this is my data set. So initially I am splitting this with respect to VAT2 less than 32, right? And 32 and var2 greater than 32. And after splitting this, suppose I am splitting again var1. So not naturally by information value it is proceeding, right? By calculating Gini it is processing in the same way with this data now. Okay, so var1 equal to maybe 1 and var1 equal to 0. var1 equal to 0. So now Now I'm seeing, see this VAT2 less than 32, and this particular line I am highlighting. It is something like this line, and this is another line, right? This particular line is basically VAT2 less than 32 and VAT1 equal to 1, and this particular line is VAT2 less than 32 and VAT1 equal to 0, right? I am seeing. So what is the proportion of A and B here? A and B in this class? 50%, right? Who asked that question?
Sir, Angela.
Angela, yeah. Angela, what is the proportion of class A and B in this
So 50
sample?
50.
50-50, very good. 50-50 means purely impure. It's impurity, highly impure. Impure means there is a high proportion of mix of A and B. But we need to move towards purity. Purity means now I am seeing here, suppose I don't know whether I didn't create the decision tree numerically. So suppose here I am getting 90% of A and 10% of B. Can I say that impure? Pure. Now is this pure? The impurity is low now, right?
No.
It's
Hmm.
no, it is impure, but impurity is low. It's mostly pure with respect to A, right?
Yes, sir.
Yeah, then we can stop. Here I am seeing, maybe here I am seeing it is 60% equal to A and 40% B. D. It is not that pure, right? It was 50% to 50%, and it is only 60-40. Then it will carry on. It will carry on further splitting until and unless there is a highly pure data set with respect to B or A. So suppose we are getting here B percentage is 82% and A is 18%. 18%. It will stop there because it's a pure with respect to B. See, 100% will not be there nowhere, because we will not be dealing with such small data. It will be a large amount of data, and from within the data, not everything will fall into single rule. There will be some impurity, but the thing is the extent of impurity. Okay, Angela.
Yes, sir. So, sir, this termination we can design algorithm that when to stop or the
Yeah,
cutoff
yeah,
we can may design.
we can decide. Yes, that this is the
Okay.
purity we need. We can
Okay.
decide. We can
Okay.
decide that. There's little bit advanced thing is needed for that, but we can decide that what should be the purity percentage for me, acceptance criteria for me.
I have a
Okay.
question here. So, is it only regarding the purity? So, purity is something which we can see at the end that, okay, maybe at the what we call it terminal node, what the purity is, but it also depends on the number of variables. So, in your example, we does not have anything. We do not have anything after var1. So we have to stop there. I mean, it's a hard stop,
No,
irrespective of the
no, no, no,
purity.
no, 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 no. We have. We can use the variable might use different cutoffs as well. The variable might, so from here it might start doing. So here where what we have, var less than 32, var2 less than 32, and var1 equal to 0, right? So here I can further split it, var2 less than 20 and var2 32.
No, but then it depends, like, I mean, what the final goal is. So are we creating bands out of our data and
Yeah,
then we are seeing, or I mean, if we are saying that, okay, we have to classify the data into
whenever,
a,
so we will not do nothing. It will calculate Gini based on different cutoffs, and it will decide where to stop based on the purity percentage. It will decide. We don't have any control. So the thing is that we can define the purity percentage acceptance criteria. That is okay. But so for now it's a simple example. VAD1 and VAD2 is also only there. So there can be 100 examples. There can be one variable as well. But it matters based on the purity. Yeah, here we don't have much option, but it can discover. So suppose we have 2 millions of data with VAD1 and VAD2 and this 2 millions of data, then it will get more complex understanding from the data. It will get there can be different segregation of VAD1 and VAD2 combinations, so different combinations. Maybe after splitting less than 20 and greater than 20, this is a pure with respect to 1. With respect to 1, it will not further segregate, but with respect to 2, it might further segregate. Now suppose it is 20, it is 20, then again it is further segregating VAT to less than 10 and VAT to less than 20, less than 10. It all depends on the amount of data in the node. See, if we have 2 data or 3 data in the node, we don't need to split. It will not split definitely. And we will get more or less impurity, but it is a huge amount of data in the node, and we are getting a good splitting criteria with respect to Guinea, then definitely it will keep on splitting.
No,
If
but then what are ultimate purpose in this? So are we creating bins or I mean the bands?
We are from the data, we are basically segregating the data into different terminal nodes.
No, but then what those terminal nodes are? So my question is,
okay,
fine with the terminal nodes, but then the classification which you are showing,
yes,
and maybe the concept of having very less Gini index, and then the node will terminate. So based on that, I mean, are we trying to create the the bands in our data or what?
Yes, we are.
Okay, so then it's relevant. I'm thinking from a perspective. So like I have seen decision tree models for LG in calculating the LGD. Or I mean, for LGD models, we usually have this decision tree setup.
Yeah.
So from that perspective, we calculate the end LGD, the loss given default.
Yeah.
So from that perspective, I was saying that okay, we know that okay, these are the variables which we have to consider, and then based on those variables or the data, we calculate our final LGD, or right. So in that case, we don't. I mean, we may not look for the Gini index or so. I mean, so it's
no. You are not seeing that. Decision tree is seeing that internally. You don't. You are just running decision tree. The fun part is in Python. It's already created. These all calculations. This is the background of the calculation. This is the black box for us.
Again, same here. So decision tree would. I mean, so this is what I think. Maybe correct me if I'm wrong. Decision tree will look into the Gini index if it has to classify things. So like I have a population, and then I want 10 bands in that population.
Okay.
So that at that point, decision tree will look for the least Gini index. And based on that, it will create 10 bands that, okay, these are the 10 classifications we can have in this whole data, or the 10 bands we can have.
So,
but then if it's a decision
classification, it cannot decide. You need to supply whatever is there. It will it will split based on that. If you are supplying some data and you don't have any Y, it will not split. That these are the classes of your data. It will not split. You need to supply that class A should, if class A, so there is a class we supplied, na?
Yes, of course. I mean, so basis that class, it will divide the data, right? So we, from that 10, I was saying that, okay, we'll say that, okay, we need these 10 classification and this is the data. Maybe divide the data into these 10 classes. So there, the decision tree will see that, okay, the Gini index is low for this combination, and hence we can have this as a class. But then I was saying that if we have to make a decision, so like will a customer will buy a home or not, right? So in these decisions, do we require this Gini index, or I mean, does this
otherwise if you are using decision tree, you need to it will go through Gini index already. You will be using some software without Gini index or without going through algorithm. If you can simply do a descriptive statistics and getting your result with a good accuracy, then nothing like that. If you are not getting accuracy, then you need to use some algorithm, and here is the algorithm for this decision. Okay, you can handcraft this as well based on your understanding of the business. Okay, so you are deciding the price range maybe. So if you have the airport distance from airport, number of hospitals, number of schools. Based on that, you are deciding. So this should be in higher price category, this should be in lower price category, and this should be in mediocre. So that is you are doing with a handcraft knowledge, with a business knowledge. You can do that, but always we cannot use those knowledge, business knowledge, out of a huge amount of data for decisioning. Then we should go for this scientific approach. Does that make sense?
Yes, and I think the problem with my understanding was the decision tree which I have seen is a
Mhm,
bit smaller and straightforward. So like
mhm,
for LGD cases, as I'm saying.
mhm,
So, but then for complex decisions like what you've said,
mhm.
so to calculate what could be the
Yeah,
price range we can
yeah.
offer, or I mean, we
Mm.
have to classify the market data or financial data. So in that case, to have a good set of variables, input
Yeah.
variables.
Good
So
set
I
of
think
variables and a good amount of records, maybe 10,000, 20,000, maybe millions. Okay, good amount
okay.
of record, then you can go for this scientific approach. Otherwise, so without with our bare eye, so we cannot will not be able to create some decisioning. So
So is it possible, like based on this, the Gini index, we may end up rejecting some variables, or
okay, so it's not variable rejection; it's a classification problem. So what I should say?
no, so this is classification problem. But then, as you've said, that if we have to like uh, decide that what price we should give to our
Mhm.
customers. So
So
if it,
you so so if some variables, yeah, it may reject automatically. It may
okay.
reject it automatically. Suppose I have a variable VAT3. VAT3 VAT3 is nothing like that 1 1 1 1 1 1 0,
Mhm.
and
Mhm.
y is my a b b c b a. Okay.
Mhm.
And 0 is B. Now maybe your VAD1, VAD2 like previous, VAD1, VAD2. See, I can see, we can see in, we can just see and understand that there is no segregation. VAD3 will be rejected. It will not be considered in the decision tree automatically. VAD3 because there is no segregation between VAD3 and Y. So one, so no difference basically.
So basically, yeah, no,
Yeah,
I mean, we will, the decision tree will not make decision
based
based
on
on
VAD3.
VAD3, or maybe, I
VAD3.
mean, there is
Yeah,
very
yeah.
less.
Yeah, yeah,
Okay,
yeah.
okay,
How
fine.
it is rejecting? It is rejecting based on again based on Guinea. Based on Guinea. First step, VAD one is winning. In the second step, in two branches now, VAD two is winning once and VAD one is winning once. The winning criteria is that lesser the better. So always it will be more. Always for VAT three, always it will be more. It will reject them. Always automatically reject them. You don't need to think about that. Decision tree will automatically reject it if we don't have enough variability explained by that particular variable. Okay.
Okay.
Hopefully this was something you have wanted to ask, right?
Yes, one of the things. So yeah,
Uh,
thanks.
uh,
So this is second here. Just to clear my understanding, you mean to say a decision tree can be used only where limited number of variables are there,
no, no,
and
no,
which
no, 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 no. Huge amount of variable are there. You can also use decision tree, but based on your interpretation. So if you have, so
so
these are
can you
all.
give me an example, means live example of anything like the one you said from airport to somewhere, how
Okay,
many
okay.
hospitals?
Okay, so maybe one particular patient will visit hospital or not. Again, visit hospital or not. The input data will be the patient's previous record with the hospital and previous health history. Based on that, we can fit a decision tree. So with a huge amount of data, whether patient will visit or not next time within next 3 months or next 6 months, whatever is the class. Okay, one. So so this is one, and another thing, visit or not. One website, maybe Amazon. One customer will be visit Amazon or not, visit or not visit within next 3 months. This is another kind of decision tree. So it's transaction history, tenure, the buying categories. Those are the driven factor behind this. Okay.
Okay, I got it, sir. So if there are 100 customers in that, looking at their what they have bought, what is
Yeah,
their
yeah, yeah.
age.
And 100 is very too less data for a statistical model. You should at least have 1000 to 1500. So decision tree not work bad in smaller data set. 1500 or 1000 data set is a smaller data set in ML. You know that already. So we need to have a large amount of data. So the data, if the data is large, the learning will be better. If data is small, the learning will be there, but 100 data will be little bit, it will be little bit difficult for 100 data. But people who don't have in basically clinical trial researches and clinical researches, I came across multiple researches, multiple theses where they collected 100 or 150 patients record. Based on that, they take decision. So then they go for 100 or 150 records. Decision tree works well as well for smaller set of data. But if it is a huge amount of data, then that will be great. The data set larger, the better. And mostly categorical variables are recommended for to use in decision tree, because otherwise the calculation time will increase, because it will split with the different cutoffs, and it will check which cutoff, basically which cutoff is actually making sense for continuous variables, like here 32, 65. So in that blog you will be able to see different cutoffs it is taking. So you got
Yes, yes, I got it.
okay.
Thank you very much.
Okay. Okay. Now, so this is so now I will quickly cover information value. Okay. See, the things might be little bit confusing, but I am not giving stress into information value. Information value is very similar to that. Very similar. So for information gain example, information value or information gain. So again, gain index. Let me find out where calculation for var1. Okay, anyways, so var2 less than 40 information gain. So this is another example. So basically information gain, this is in information theory, it is defined as p log p, p log p, p log p. This is the information value. Hmm. So log 2, don't get confused of that with that base. You can take other base, this is just a matter of scaling. Okay. So now for VAT2, this is the proportion. Similarly, it is calculating the proportion. Similarly, it is calculating the proportion. Okay. Just see this example, VAT2 less than equal to 45.5. Okay. So basically here the uh, number of observations are zero. Number of observations are zero. That's why it is not mentioned over here. It is only 2 by 2. That is the weight. And before minus, okay. So this is minus p log p. Minus p log p is the information, and actually it is quantified as minus p log p. So that's why there is a minus p log p. So this is the weight. Weight is 1, 2 by 2, 2 by 2 instances. Total var2 less than equal to 45.5. There are 2 instances. Okay. So that's why 2 by 2 examples equal to 8. Okay. And similarly for var2. So this is, and finally there is a weighted average in the similar way. The formula is different. There it was 1 minus p1 square minus p2 square. Here weighted average of the sum of the weighted sum of the p log p minus p log p. P is same, the proportion only. Okay. So information value of VAT2 equal less than 65.5, etc., etc. Everything is provided over here. Now the decisioning again. So whatever quantity we are calculating over here, lesser is better. See, this is for 7.77552. Here
So
it is
for information gain also lesser is better, or it's
no, this particular value it is calculating. So if we minus
yes.
that from 1, that will be the information value. Information gain, if information gain is more, then, but we are keeping this simple. We are not subtracting from anything. If we subtract this from 1, then it will be the final information gain, but we are not subtracting over here. Okay. So if information gain is more, then this is the decision. But if we are seeing this weighted sum, then lesser is better. Okay. So to create an create a coordination between Gini formula and information gain, you can remember this. This will be helpful. You don't need to minus it from 1. Okay.
Exactly. I mean, we don't subtract this.
Yeah. So it is not given here. The sole purpose is so that you can remember Guinea and information again in the same manner, Okay. Okay, but it is just for concept. You don't need to write any code for this. Okay, if you try to code, you can also will be able to, because codes are already there. You just need to convert this function in your own language, whatever language you are using. Okay. So now let us open the so can you just open the Python code for decision tree, please? I have shared that decision tree IPNB. Please let me know once you open this. Okay. Hello. You're opening in Python, this Python data, right? This Python file. Once you are open, just give me an answer, please, because I want everyone, whoever for which is possible. I want for everyone the. Uh, okay, so you got answered. Okay, please respond here after opening the code. Please respond.
Yeah, I have this open.
Okay, good. Well, quickly. Please open this. Let's understand it practically as well. The decision tree. Please respond. You are not opening this Python. You don't have Python installed in your system, everyone? If you are not, let me know. I will help you to install if you are facing any problem. Okay, that's not a problem. Nobody is responding. Why? Nobody is opening.
Sir,
No,
I
no,
have
opening.
opened.
Okay, please let me know. Yeah. So Janvi or Angela, you are saying something, right? Tell me.
Yes, sir, I'm opening that.
Okay, very good. Open that in Jupyter Notebook or whatever GUI you are using.
Yes, open.
Okay, open, right? Okay, let me start them. So these are the packages we need. sklearn, you already installed this, right? If you don't, you have this not installed, then please install this. Pip install sklearn. That's it. Okay. And np, pd, pandas and numpy. These are already installed, I believe. Okay. So these are the libraries we are calling. From libraries, particular modules we are calling. So now it's a couple of functions. It's a formal code. So though you are learning this, so it could have been a code which is vanilla. So I just collected one code which is a formal one. So first one, there is a function import data. Okay. Second one, so what we need to do in a classification problem. So we discussed test and train set last class. Test and train set we discussed. For forgot. Hello. We discussed training set and test set in last class, in logistic model class or any other class taken by
Yes,
Sabato sir. We know test and
in
train set. What is
logistics.
test set and train set?
Yes, yes, you know.
Okay. So what is train set and test set? Any volunteer can we have?
I mean, train set is used to train the data which we have, and I mean, train the model basically
Okay.
based on the data which
Very
we
good.
have.
Very good.
And test set is, I mean, we when we try to test the model and see, I mean, what the
Very
accuracy
good.
is.
Very good. So any criteria for classification in to create this test set and train set? Any criteria we should need to follow?
Usually, it's 8 by 2,
It by
80%, 20% split.
okay, 80%, 20% split. Okay. Any other criteria?
Random plus certified sampling.
Ah, stratified sampling. Very good. Gaurav, you also very good. You answered. See, hmm, see, I'll explain quickly. Okay. See, so we have a data. We are creating a model, sending to customer. The model sending to customer. Customer will ask that will your model work? You will say yes, it will work. So where is the test report? So how you test it? So that's why we need to not only create model, we need to test the performance of the model as well. How we can do that? We have only this data, na? We don't have anything else. Performance, how we can judge? We can judge whether it is correcting, predicting correctly or not. So that's why we need to split this data into two parts. One is training data, maybe 80% or maybe more, and one is test data. Test data. 20%, 20% or accordingly 85 15 can be as well. Okay, another criteria we need to follow. Suppose we have in class y, like here class is a and b, a and b, a and b was 50-50, that is 1:1 ratio. So after splitting here should be it should be that this the train set should be 1:1 with respect to ab, and test set should be 1:1 as well. Okay, if class is this, if class have three variables, so a b and c, and the proportion is 1:1:2, then here also in training set also it should be 1:1:2. In this criteria we should be, it is random sampling but it should maintain this proportion. This is called stratification. Okay, if someone wants to know why, then I will explain at the end of the class. Okay, because I already explained this I believe in last class, but I can explain another time. Plus note that question if someone have questioned why we are doing this. Okay. Okay, now that is getting done over here. Here we are doing this. Hmm? Here we are doing this import data. Okay, sorry, here we are doing this splitting the data in this function. So first we are importing the data. After that, importing the data, after consuming the data, we are splitting this to train and test set. And this is the code for a train test split. It will automatically, you need to declare the y variable only. Y variable. It will automatically calculate the y, the different values within y, the proportion of it, and accordingly it will create the test set. And so here we have taken 70% and 30%. Okay, and random set 100 means the similar same list of same set of randomization it will appear, because suppose I am running in my machine, I am getting 85% accuracy. Okay, okay, so now again I am running without this random set 100, again it is creating different set of samples, x train and x test, and the accuracy is coming as 84%. Then client will ask me, you told me 85% but it is 84%. Why? Because the train set and test set have been changed little bit. So in little bit differences are there in train set and test set. But to prove that whether I got 100%, I got 85%, I need to reproduce that. So this random state is basically in my system. This random state will preserve the exact training and test split what we used to get 85% of accuracy. That's why this random state is important. Okay. So anyone who doesn't understand this? Okay. I'm assuming you understood. Now train using Guinea. So now we have training set and test set. Then now we need to create the model. Simple. See decision tree classifier, you can declare this Guinea, and you are defining the max depth as well. So Gaurav, another question, you can control where after which step it should stop, maximum how much maximum depth you are allowing as your acceptance criteria. After that
Okay.
it will stop. It's matter of purity or impurity. It will just calculate based on the percentage, majority percentage. Maybe 5149, it will predict as 51% class. Okay. So
Yes.
okay. So now CLF Guinea, X train and Y train. Okay, so this is something performing training. So it is, oh yeah, this is just running the model. This is declaring the model, and this is running the model. This line is running the model. Okay. Now next, train using entropy. Same thing. The fun is here you need to write Guinea, here you need to write entropy. That's it. Okay. Now CLF entropy again. So see, train using entropy is return CLF entropy. Right. Now call
And
accuracy
what's
Y.
this minimum sample leaf?
Minimum sample leaf. Minimum sample leaf means so at the end if it is less than 4 it will not consider. See, I will tell you. Good question, and thanks for asking this. I was missing this. So basically this is your decision tree. This is your decision tree, and these are your this is your decision tree. These are my terminal nodes. Okay, oranges are my terminal nodes. Terminal nodes. Now, so every node is a data set. Do we understand this, Gaurav? Every node is a data set.
Yes.
Okay, very good. Now this terminal node is also data set. Data set should have a number of records as well.
Okay. Yes.
Okay, that number of records is this. So it should not be less than
Okay.
5. That's what it is saying.
Okay. Okay.
Okay.
Fine. Yes.
Okay, if it is less than 5, so suppose this is less than 5.
I leave it saying no nodes.
This is 4. This is 3. Maybe this is 3 and this is 4. Or maybe this is 20. See, this is 20 and this is 3 further. So what it will do? And here it is 23.
Yes.
From 23 it is coming 3 and 20.
20.
Then what it will do? It will reject this further branching. It will discard this. It will discard this.
Discard only 3, or I mean split.
Both. It will
Okay.
discard this and it will stop here.
Okay. Discard the split.
Yeah. This is it. Sorry. Discard the split. This is called pruning the tree. Pruning means pruning activity, you know, na? Pruning
Yeah.
activity, I can show you. YouTube pruning tree. Pruning trees.
Basically,
these are
rose plant we do the pruning.
yeah. So there's it. Prune them means prune them. You are the extra branches you are pruning to get a. Let me. So I'll share one pruning video if you don't understand. But pruning means extra unnecessary branches we can cut to keep the tree in shape and healthy. The extra unnecessary small branches someone cut for a better visibility in most of the cases. That is called pruning tree. It is nothing but a pruning tree. It doesn't make any sense. 3 very observations only. Doesn't
Yes.
make any sense as well. So that's why it is stopping here. Okay. Now prediction. Now it is predicting. Now this is CLF object, which is the model, and predicting X test. X test. Where we created this X test, here we created this X test, right? Okay. Now Y predict, and now accuracy calculating. We are calculating the accuracy, etc., etc. Okay. And now this is the main function. In main function, we are just calling this function. First importing the data. After that, we are splitting the data. See, this is the main function. Splitting the data. Then after that, we are using the Gini. We are using the entropy. Do two different names: CLF Gini and CLF entropy. Y pred Gini, CLF Gini X test. So this prediction is another time it is getting called, and it is passing the CLF entropy, and very simple code but formal code. This is a production level code. It's a very classic production level code. Okay. So there are many examples in online available, but this is very standard. I found this very standard for decision tree. So that I just pick that. Okay. So now one thing. So you understand confusion matrix? I described confusion matrix in my last class. See, this is
Yes. 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 Yes.
okay. You understand. So everybody is not very comfortable with confusion matrix. I can discuss shortly another time. Let me know. I have another session with you, 2 hours. So I can discuss that as well. If you really want to understand confusion matrix another time. Okay, no, then that if you understand, then that is fine. See this calculation. If you understand, so someone can explain this calculation to me from this. This is the confusion matrix. See, 067. Let me write it clearly. There are three classes basically in the data. In the data, what we have taken here, example data set, right? No, iris data set. In this iris data set, let me CSTL data set, main function code data. In iris data, just give me a moment. Okay, no. Okay, so in here, from here it is taking the data, right? So let me run this line. We'll get to know. This is rough. This is the data set. In this data set, what we are actually doing, let us understand the objective. So B and R, this is my class B, R, and L. Okay, and these are four variables: 1, 2, 3, and 4. 1, 2, 3, and 4. These are my four independent variables, and 0 is my dependent variable, which contains three classes B, L, and R. Right now, confusion matrix will be like this. Then let me write it here in a where is that? Yeah, confusion matrix is BLR. Yeah, see, 067, 067, 067, 18. 067, 067, 18, 0, 1971, 0, 1971. This is probably actual, and this is prediction. Okay, now B, L, R, and here also B, L, R. BLR. BLR. Okay. Now tell me, what is the total actual B? Total actual B. Hello. Total actual B. This is B. This is B. Okay. Pardon me for
All
my
B is 6 plus 7.
6 plus 7. Very good. 6 plus 7. How many correctly predicted?
B 0.
0. Then recall. Recall is 0 by 6 plus 7. So let me write it. B L R B L R. Now total is 6 plus 7, 13. How many correctly predicted? Correctly predicted 0.
0.
Okay. Total actual. This is total actual. How many total prediction? Total prediction A. Total P. Total predicted B. How many?
0.
0. Then recall and precision will be this. Precision. Recall precision. Recall means correctly predicted by total A. 0 by 13. And total P is total predicted. Correctly predicted by total predicted. Here it is undefined. You can assume that as 0 for this case. Precision is 0. No prediction, nothing predicted. 0 by 0. Total predicted. This by this is precision. This by this is recall. Now for A, give me these numbers. Give me this number. Total A. Oh, BL. Total L. Total L. How many? How many total L?
85.
85. Very good. How many correctly predicted?
L. 67.
67. Okay. How many predicted? Predicted means you need to sum this. Predicted means you need to sum this. Actual means you need to sum this. Row wise.
86. 92.
92. Recall?
Recall is 67 by 85.
67 by 85. Very good. Very good. 85. And precision is?
Precision is way much as in 92 by
Precision is total prediction will be in denominator.
okay, sorry, 67 by 92.
Yeah, the numerator will be always same. 90. R. What is R? R. Are anyone else? So who answered those? Soikot. Sandy. Okay. So who wants to answer for this? At least try. Don't afraid. Just try. You will understand easily. Anyone else than Sandy?
Okay, I can
Go up. You also answered many questions. So let's show up. You want to answer? Show up. Okay, Gaurav, go ahead. Yeah, tell me.
Okay, so the total R predictions are 19 plus 71, which is like 90.
Okay, so
correct predictions are 19 and total sorry, 71.
71.
sorry.
No problem.
71, and then total predictions are 71 plus 7, it's 78 plus 18, uh, 86, 96.
90,
And
71.
sorry,
Yeah, this is 0, 19, 90, 71 plus 19, 90.
no,
Okay.
total prediction is 7 plus 18 plus 71, no?
Yeah, 100%. This. I was
Yes.
checking this. This is
Okay.
correct. This
Yeah,
is
yeah,
also
yeah.
correct. This is also correct. Good.
Yes.
Now,
So our recall is total number of correct predictions over the total predictions, which is 71 over 90.
okay.
And then our, okay, yeah. And then our precision is total number of correct predictions upon total number of predictions.
Very good. Then 71 by
96.
very good. Okay. Thank you, Gaurav. Gaurav, can you explain the class how you are finding this number? Quickly.
So 90, we are saying that, I mean, how many total predictions are made for R? So which is the row in front of R. So it's 19 plus 71. And then the correct predictions, if we see, so that should be the cross point
So
of
first we are summing
R,
this and
R versus R. So
getting
that's, yes.
and then second we are summing this. We are summing this and getting this.
Yes.
And this is the joint. This is the function R and R, actual R and prediction R. This is the joint.
So
Okay. That's it. So now you understand decision tree will be, so just remember that block and save that block because you learn from there. It will be helpful for you going forward. Okay. Okay. Any other question?
Sir, this confusion matrix, can you, this last part, recall and prediction, for that, can you explain with some real life significance?
100, yes, 100%. Let me explain that in the next class. Good question. I will explain that. Okay. Why this is important. Any other question? So you can you invest another 5 minutes? Then I will. So okay, let's discuss that in the next class. Let's discuss that in the next class. No worries. Any other question apart from that? Okay,
No.
then let's take a break. After that, we'll start. Okay, we'll start, and that will be easier, and that will be fun basically. Okay, so we don't need to do any mathematical calculation and all. We just need to understand the concept. So some concepts are there, very important, but it will be fun, and it will be a very advanced algorithm. Okay then. Okay, then how can I stop the recording? So why I'm facing problem, I don't know. Yeah, stop recording, right?
Yes.
Okay.